Okay. So this lecture will start with sort of the last slides from dynamic experiments, which I've now moved out of the dynamic experiments into a new set of slides. So if you go to the course page, you'll see them sort of these feature point slides, which are separate. Again, this is a topic we won't go into a huge amount of detail with, but given its sort of prominence in technology products today, I figured it would be useful to cover. So again, this sort of has its own specific reading. This is just the very, very introduction to this material. There's obviously lots and lots more you can read on it, but these I found fairly helpful to get started. So the idea of sort of key points or feature points is that rather than, as we talked about in the last lecture, sort of trying to track individual objects like cells or tracking sort of groups of pixels or voxels using some of the deformation techniques we covered, that you can actually just use key points where you try to identify sort of unique or special areas in the image, and then you follow them through all of the different time frames or between two time frames. And so the idea with this is that, with cells or objects, they look often similar. You have to first be able to identify them clearly. In many images, that's not very easy to do. And with sort of normal images, if you try to just match images to each other, this is very, very time consuming. Whereas if you can find a quick way to identify key points, then all you have to do is match the key points to each other. So sort of the idea for this is that, for example, one of the detectors, key point detectors we have is sort of this corner Harris. And we don't really have to worry about exactly what it does, but basically if we take an image like this, we have this sort of checkerboard pattern. And what corner features does is it sort of highlights features that look like corners. So it's kind of an edge detector in sort of two directions. And so we get this image out of it where we see these black points are possible corners. And then if we run the corner peaks or the corner extraction from it, then we get all of these individual points as sort of unique features in our images. And so for simple scenes like this, or if you're walking around a room and you have lots of computer monitors in it, corner features tend to work quite well because corners are sort of unique shapes. They tend not to change very much, and you can kind of track them through time. We can sort of do the same thing with normal images. So we can take one of the bone images that we had before. We can apply this sort of corner feature transform, and then we get the corner points of this object. And so what we end up seeing is that sort of, this boundary looks sort of like a corner in both directions. This here, this here, this here. And so it's kind of a mixture between finding objects and finding pixels. And so it's just a quick way of taking our image and turning it into a bunch of points that we can proceed to sort of track easily. And so what's quite nice with this is that they're now fairly easy to track. And so we can calculate all these points and track them through the image as if they were cells. And so here, if we look at sort of a grid that's being transformed, we can see that our ability to sort of detect corner points, we find the same points as the image moves, shifts, scales, rotates, everything else, that this is a fairly consistent way for us to kind of identify and track changes that are going on. So the same points we see at the beginning, we also see sort of after quite a few different transformations have taken place. And so now we can move beyond just sort of the key points to key points and feature vectors, or as we call them here, descriptors. And so basically what they include are their sort of little codes or feature vectors that describe that key point uniquely. So they say something about sort of its surrounding, what it looks like, the patterns nearby, and that all gets incorporated into the image. And so we can show here, we can use a different detector. This one's called orb. You can read the details of the papers. They're sort of quite mathematical and theoretical. But that basically what we have is we get these, not 10 different key points throughout our image. And if we look at sort of the descriptors for each one of these 10 points, this uses a binary descriptor, which means at each spot in the vector, it's either 1 or 0, and that each one of these key points sort of has a unique barcode describing it. And so this is binary because it makes it a lot faster to search so that you can match them quite quickly, because often you'll have thousands of key points that you're tracking for hundreds of frames, and you want to be able to match them together quite quickly. So we can then apply this to sort of real images, where we take an image and sort of shift it, and we can see in this the key points that it found. So all the points represent sort of key points, and all the lines represent sort of the best matches between those key points. And so we're able to take an image like this, put it in, and it's able to kind of show us which points match in image 1, which is on the left side, match to which points in image 2 on the right side. And here we just then show the feature vectors for both of those, and we're able to see sort of how those two images kind of track together. What's then very useful about doing this is that we see that not all points track to the same sort of offset. And so in our image, we know, this has just been shifted up to the right. And so anything that was shifted up to the right by a certain amount is probably a good match, and anything else is probably a bad match. And so we're able to go through and sort of, ignore these kind of minority cases where it's going in the wrong direction or matching to the wrong thing. This one was using just the corner and peak detection there. And so this one didn't work particularly well. So the corners were reliable. We see that the same points sort of show up in both images. But the feature vector was too simple. So just using corner information wasn't descriptive enough. And so here, using orb, which is a more complicated feature descriptor, we're able to sort of detect similar points and see that we get a much better consistent tracking over the image. So that when we look at what tracked in image 1 to image 2, we see that almost all of them tracked in this direction, and that there's just a few which seem to be kind of completely mismatched. But here it's then very easy to say the majority of offsets are in this direction, therefore that's the most sensible shift for that image. This then feeds in quite well to the exercise material, where we do this for sort of scans. And so trying to register multiple scans together, that you have sort of like this pollen grain that's being rotated. And you can use these feature descriptors. So here we just use orb, and that we match points between the first image and the second image then the third image then the fourth image, and then sort of track how all of these looked and sort of make a plot of all of the sort of movement of our key points matched by feature descriptors over the image, and so that we can start to see at different angles how do different points in the image move. And so we see that these ones move quite straight, and that as you get up there, it becomes more sort of a turned, jagged point, which tells us a lot of information about how far away the object is from the camera and some of the 3D information. And so by taking all of these points and extracting them and tracking them, we're able to come up with much more 3D information about what we're looking at. So then there's more examples here where we try to change it and then fit it to some values, and there's still much more analysis you can do here, but that's the sort of the basic idea. Similarly, I think drone videos. This is quite popular or quite important with tools like drones. Where if you have sort of a video here, this isn't a great example, that a lot of drones have a number of different cameras on them, and that they try to track how the world is moving because they have GPS sensors, they have accelerometers, they have all kinds of different devices inside. But one of the most reliable ones they can use are these sort of camera setups where they can see how the world's moving, they can track points in the world, and then use that to determine how the drone must be moving. And so here you have sort of a video sequence where you detect feature points, you track the feature points from one frame to the next, and then you have sort of an understanding of how the world is moving or how the drone is moving around the world. And so it's quite a useful technique for processing video data very quickly because, a drone has a very limited amount of compute. It's not a huge device. It can't do all its analysis in the cloud. It has to do it on fairly small chips. And that doing these sort of feature point detection and tracking works fairly well, and you get sort of fairly reasonable results. So the motion of the scene is predicted quite accurately. This is also sort of what humans do. So when you're sitting on a train and the train next to you starts moving, your eyes see that, you're tracking points on that train, and you feel like you're moving because your eyes are tracking those objects. At some point, you sort of have this mismatch where you realize you're not moving and the other train's moving, but that your sort of perception of motion is based on sort of tracking these features and points in space. So that covers it, I think, for that topic. Again, we don't go into much detail on this. We'll have a few exercises and links to other things if you're interested, but for more detail on this kind of analysis, really you'll probably need to take a full-blown computer vision course because they're fairly complicated techniques and require quite a bit of theoretical understanding to employ them. And the point for this was just that you're sort of aware of how these work and understand sort of what tools are easily available and are able to kind of try simple approaches for this kind of tracking. So are there any questions on that? Otherwise, we'll shift gears to sort of the statistics slides. This is what we're